Hello, calculus fans! Let's evaluate the triple integral over e of x squared plus xy squared dv. And let's say that e is the solid region in the first octant that lies beneath the paraboloid z equals 9 minus x squared minus y squared, but outside the cylinder x squared plus y squared equals 4. Let's take a look at the projection of e into the xy plane. It's going to be the first quadrant sector of an annulus centered at the origin with inner radius 2 and outer radius 3. Here's the picture. The lower bounding surface of E is z equals 0, that's just the xy plane, and the upper bounding surface is z equals 9 minus x squared minus y squared. In cylindrical coordinates, we could say that that upper bounding surface is 9 minus r squared. That means we can nicely describe E, the solid region, in cylindrical coordinates like this. It's the set of all points r theta z, where theta goes between 0 and pi over 2, r goes between 2 and 3, and z goes between 0 and 9 minus r squared. All right, let's evaluate the integral now. When we evaluate the integral, the first step is to factor out the x, because after factoring out the x, we get x squared plus y squared. That, of course, gets very naturally converted in cylindrical coordinates. And so, when we write down our integral, we'll get the integral from 0 to pi over 2, the integral from 2 to 3, the integral from 0 to 9 minus r squared. So outer to inner is theta, r, and z. Then this x here gets converted into r cosine theta. This x squared plus y squared gets converted into r squared. And then why do we have this r? Same deal as always. That's our scale change factor that just has to go in when we convert from rectangular to cylindrical coordinates. And we're integrating in the order dz dr d theta, so the innermost integral will be dz. We'll simplify that, so the integrand just turns into r to the 4th cosine theta. Evaluate that inside integral. Very easy because there's no z involved. Now we have to plug in the 0 and the 9 minus r squared. Here's what we get after plugging in that 0 and 9 minus r squared. Very happy, of course, to have this 0 here. Now we can factor the integral, separate out the theta and the r's, and that's because the limits of integration are all constants. The rest of the computation is fairly straightforward, and I'll leave it to you to work out the details. You're going to end up with 2,998 over 35. Okay, that's all for now.